Okay, here's a quick solution for easy problem number 1, kinematics, and you can see how I would solve that. This is a vertical problem. I'll scroll down. You guys can reference the problem on your sheet, but you always want to model it by drawing a picture first. He drops the rock. There's the top. Here's the bottom right before it hits the water, and I'm going to define my coordinate system. This will be my origin at the bottom, and the positive y direction, we usually define that as up. And then we'll go through and fill out our information. This will be our initial. We'll call that y. My initial y. We don't know the height. My initial velocity. What he drops starts at 0 meters per second. There's no velocity to start. My acceleration. Since it's in free fall, it's always negative 9.8 meters per second squared, neglecting air resistance. My time is going to be 0 seconds from the top. At the bottom, y1, so my next point, or my displacement here, this is my origin, so this is going to be 0 meters. My velocity at the bottom, we don't know, we're going to solve for it. My acceleration is the same, it's still in free fall right before it hits the ground, or hits the water. So 9.8 meters per second squared. And my time, he counts, oops, this should be 7 seconds. And our first question asks us how fast is it going at the bottom. Now we're going to solve for velocity, even though velocity is not our speed. I'll talk about that in a second. But we want to know how fast it's going at the bottom. So we're going to use this equation. My final velocity equals my initial velocity plus my acceleration times my time. If we plug in here my final velocity equals my initial velocity, which is 0 meters per second, plus a negative 9.8 meters per second squared, times my time period, which from 0 to 7 seconds, we have 7 seconds elapsed. And if you calculate that out, we get a negative 68.6 seconds. And that's just saying that the negative is saying that we're traveling downward. Since the problem just asks how fast it's going, we would give a magnitude of that. So the magnitude of that vector is 68.6 meters per second. And that's how fast we're traveling, about 150 miles per hour. How high is the cliff for part B? Come back down. How high is going to be figured out by finding this value right here. And to do that, we use our kinematics equation. My y final equals my y initial plus my initial velocity times my time plus 1/2 a/t squared. And if we're plugging in my final position, this will be my initial position, this will be my final position. So my final position is 0 meters. My initial position I'm going to solve for, plus my initial velocity. Well, here's my initial point. My initial velocity is 0 meters per second. So this whole term becomes 0 times 7 seconds plus 1/2 negative 9.8 meters per second squared times 7 seconds squared. If you solve for y1, this is all negative. The square negative becomes important. You add that negative to the other side, and it gives you a positive y1 value and y initial, which is my y0. And this comes out to 240.1 meters. And it should be positive. We're going from 0 all the way up. So that'll be my answer for part B, 240.1. And to answer part C, should he jump? Not if he wants to be safe. And that's it.